Welcome back to Maths with Mrs. J. We've started a series of videos about integration. And you might remember from our first video that integration is the same thing as anti-differentiation. It is going back the other way. So all of our rules, all of the ways that we integrate require us to have a very good knowledge of how we differentiate, and basically we do the opposite thing. We've started off with polynomials, and you might recall from our previous video that if you're integrating x to the n with respect to x, we increase that index by 1 when we divide by that new index, and then we have this constant term coming in. Sometimes we will know information or have information that will enable us to find what that constant is. Sometimes we won't. Let's go through a few more examples. Just bear in mind that quite often with integration, it might be helpful to do a little bit of work on the expression first before you try to integrate. And I'll explain that as we go. I've also deliberately used different terminologies here. I've said find y if dy dx is this, find f of x if f dash x is that, find g of x if g dash x is that. In every case, I'm asking you or us to anti-differentiate or integrate. All right, let's get started. Now the first one here, the format that it's in is not particularly great in order to integrate. So let's put it into index notation. So we're not doing any integration just yet. We're just changing into index notation. So x, the square root of x is x to the half. And remember that if you have your x cubed in the denominator, that's the same as x to the negative 3. Right, we haven't integrated yet. We've just rewritten our dy dx in a more appropriate version that will help us integrate. All right, so now we can use our rule. So our rule says that we increase the index by 1, so it'll be 3 on 2, and divide by the new index. We increase the index by 1 and divide by the new index. We increase the index by 1, and that was really x to the 0, and we divide by the new index, and of course we have our constant term. We're not actually given information in this question to find that will enable us to find c, so we'll just have to leave it as a c. What we don't want to do is leave it looking like that. It looks a bit like a dog's breakfast, so we're going to rearrange this. I generally like to give my answer using similar terminology to the way the question is written. So there's a square root sign here, a radical sign here. Now you're dividing by 3 on 2, that's the same as multiplying by 2 on 3, so we're going to get 4. Now x to the 3 on 2 is x to the 1.5, isn't it? So that's the same as x root x, and that's all over 3. Now, we're going to get a minus here, 3 on 2, and this x to the negative 2 becomes x squared in the denominator, minus our 4x plus our c. All right. Next one, we have a product here. Now, you hopefully will recall when we were talking about differentiation that sums and differences are okay. You can just differentiate each bit and add them or subtract them. The same thing works for integration like we did here. You just integrate each bit and add or subtract. Products and quotients are different. We know we have special rules for those. Ideally, what you want to do is avoid having to use those sorts of rules in reverse with integration, mainly because unless you do specialist maths, you're probably not going to even learn rules for dealing with a true product. We'll deal with things like what I call chain rule in reverse in our next video. We've got something here that's very easy to just expand out. So why don't we do that? 3x times 2x is 6x squared. We've got minus our 15x minus our 8x plus 20. So this is just, of course, 6x squared minus 23x plus 20. Now, we haven't done any integration yet. We've just expanded out our bracket so that now we have a sum or difference. So now we can get our f of x by integrating. So we're going to increase our index by 1 and divide by the new index. Increase our index by 1 and divide by the new index. Increase our index by 1 and divide by the new index, which is 1, plus our c. Let's tidy this up a bit. So f of x is 2x cubed minus 23x squared on 2 plus 20x plus c. Now I'm going to set aside a little bit of working space over here for us to work out our c. We are actually given information in the question that will enable us to do that. We're told that when x is 1, f of x is 8. So let's sub that in. So 8 equals 2 times 1 cubed minus 23 times 1 squared on 2 plus 20 times 1 plus c. If you fiddle around with that a bit, you get 2 minus 11.5 plus 20 plus your c, and you end up with c is negative 2.5. So your actual function, subbing that back in now, is going to be 2x cubed minus 23x squared on 2 plus our 20x minus our 2.5. All right, last one. Again, I've deliberately picked this one because it's a little bit different. We have a quotient. We don't know how to integrate quotients at this stage. However, we're lucky, we've just got one term in our denominator. So why don't we divide through each term in our numerator by this x cubed. So x to the 4th divided by x cubed is x. Minus 2x cubed divided by x cubed is minus 2, plus your 5. And I'm going to write this as an x to the negative 3, preempting the fact that we are going to be integrating, and so that's a good format to have that in. All right, so g of x, integrating, we're going to get x squared on 2 minus 2x, now plus our 5x to the negative 2 on negative 2, plus our c. We must not forget that c. Let's just tidy this up a little bit. So g of x is x squared on 2 minus 2x, so minus 5 on 2x squared plus our c. Just remember, if you have a negative index, that's the same as the reciprocal, so that will end up in the denominator. Now, we're told information in the question that will enable us to find c, just like we were in example 2. So 5 is 1 squared on 2 minus 2 times 1 minus 5 on 2 times 1 squared plus c. If you fiddle around with that for a bit, you get that 5 is a half minus 2 minus 2.5 plus c. What do we get? We get that, so in this right-hand side, we get negative 4 plus c. So 5 is negative 4 plus c, so c is obviously 9. So putting that into our formula or into our equation for g of x, we get that x squared on 2 minus 2x minus 5 on 2x squared plus our 9.